Hey guys, got my work done in the last couple hours. I've just been messing around with some free time, so I've been studying the pyruvate dehydrogenase complex. So really quick, I'm a molecular bio student at University of Hawaii, but I have ME/CFS, and for like the last 4 years, I've pretty much been bedridden, and it's just about killed me. But now I'm in school again, finally, thanks to drugs. Because I'm still sick, so I have to take my Daphanol every day. But it's still a big struggle, but learning a lot of stuff. So, why I studied this complex, pyruvate dehydrogenase complex, is this. A year or two ago, one of the leading ME/CFS guys who's on the Open Medicine Foundation board, and I think Ron Davis, both of these guys and his team, found that when you take ME/CFS patients and compare them with normal people, something called pyruvate dehydrogenase, or the pyruvate dehydrogenase complex, is inhibited. It's not working in ME/CFS, right? So, really quick, glucose, just the sugar, goes in and it gets converted in a 10-step process called glycolysis with 10 enzymes, and it throws off things like NADH and a little bit of ATP, but the whole point is it turns the glucose into pyruvate. That's like what mitochondria eat almost, right? Think of it as mitochondria food. And then from there, pyruvate dehydrogenase is the gatekeeper to the mitochondria. It takes the pyruvate and turns it into acetyl-CoA, which has stuff like a I can't even talk right now. Phosphoester? Oh, it's a thioester bond, I'm sorry. Which is like explosive, it's full of energy. At that point, it goes into the mitochondria and goes into something called the citric acid cycle, or the Krebs cycle, or the TCA, and that makes more ATP. But most importantly, this crazy, really fast biochemical cycle inside the mitochondria throws off electron carriers, which are really important. So those are old NADH, FADH2, stuff like that. And those things go into the electron transport chain. So from there, they go into the matrix, in the walls of the mitochondria. It's like all curvy like this. It's a matrix, but in the wall, there's these really just a little complex called the mitochondrial electron transport chain, and the electron carriers go into it, and it just spits out ATP like crazy. And ATP is the fuel of life almost, right? It's like what cells run on, what brains use, what everything in the body uses. If you don't have enough ATP, you're going to be extremely exhausted and really sick, and it's going to have a plethora of effects, including messing up your immune system. But the gatekeeper to making acetyl-CoA, again, which will eventually make the electron carriers that go into the electron transport chain that makes our ATP, this gateway is inhibiting the pyruvate. It's shutting it off, so no fuel is going into the mitochondria, really. There's alternate pathways, but they're very weak and not substantial. So nothing's wrong with our mitochondria. There's no evidence of that at all. Generally the people that say that, they're very far from scientists or anything. Some of them are predators, I learned, but I spent thousands of dollars on bullshit, but before I was educated. So mitochondria is fine. When they do get damaged by like a mutation, you get Huntington's disease. I'm not going to go into that, but it's nasty stuff. So mitochondria is fine, but they're just not getting the fuel they need. It's that simple. So again, what's cutting off the fuel? It's pyruvate dehydrogenase. So let's learn some stuff about it. I'm not going to explain how it works because it's really technical. It's full of like organic chemistry, biochemistry, words like dihydropropyl transacetylase. We don't need to learn about that stuff right now. It's like not that important, but this is what it looks like. It's composed of 3 modules. or 3 little parts, E1, E2, and E3. Okay, so yeah, I'm not going to explain how it works, but I'm going to explain how it's regulated, because ours is like turned off. So it's like, and I've been reading this book, and talking to the author a little bit via email. It's like one of the leading mitochondrial researchers pretty much in the world, or at least the country, but so let's get to it. How it's regulated. Activity of the pyruvate dehydrogenase complex determines whether pyruvate is oxidized, which is where it just gets an electron taken off to CO2 and H2O, or it's converted to lactate. And I know we already have a lactate problem in ME/CFS, you know, the lactic acid stuff, I think. Tons of it. I'm going to come back to that. So, for example, injecting pyruvate in an IV, what do you think is going to happen? Well, it has to get through pyruvate dehydrogenase first, and it's not. So you're probably just going to make them sicker if you inject pyruvate. And it was done, and it made them sicker, and they got full of lactic acid, I think. So, a little confusing. So the pyruvate dehydrogenase complex now is inactivated by phosphorylation. What phosphorylates it is pyruvate kinase. A kinase is an enzyme that adds a phosphate group. So remember, you know, the element phosphate? So it just, pyruvate kinase just puts a phosphate onto, I think E1. Yeah, E1. So it puts a phosphate on, but guess what happens? It just inhibits and shuts off E1. As a result, E2 and E3 aren't going to get anything, so it's just like, think of it like this, and the stuff flows through it. Well, this is plugged up, so it's going to be like, you know. So we got a problem there, and it's not quite this simple at all. It works on a negative feedback loop, but we're not going to go there. E1 gets activated by pyruvate kinase. So how can we turn off pyruvate kinase? One thing is dichloroacetic acid turns off the pesky pyruvate kinase. Now phosphorylation is also reversed by pyruvate dehydrogenase phosphatase. So that's kind of a weird fucking thing. Like, it's not practical. How do I go get that at the store? Well, it's stimulated by insulin. So insulin stimulates pyruvate dehydrogenase phosphatase. That inhibits pyruvate kinase, and that way E1 doesn't get phosphorylated, and the thing will still make the juice for the mitochondria. There's one thing. And then also phosphoenolpyruvic acid also also activates pyruvate dehydrogenase phosphatase, which is the one again that inhibits pyruvate kinase. And it works on a negative feedback loop, like I said. So this is really counterintuitive, but taking NADH, like Inada NADH, I've done that a lot, it can possibly make you actually sicker because it inhibits pyruvate dehydrogenase phosphatase. Because like if you have too much NADH, it's just like the HPA axis, right? So if you have too much NADH, it's going to inactivate it, it will slow down, and you won't get too much. But if there's not enough, ideally, it won't get activated, the pyruvate kinase, I guess, and you'll make more. So again, taking NADH tells your body there's plenty of it, and it will just engage the negative feedback loop and inhibit pyruvate dehydrogenase phosphatase, which inhibits pyruvate kinase. Oh wait, yeah, which inhibits it, but this isn't getting activated, so the pyruvate kinase is going to do that shitty thing, which does so it's a little bit of information. So the idea now is just, what if insulin could help? I mean, you have nothing to lose. Insulin might get that old pyruvate PDK complex going, get more ATP made, so insulin. And then lastly, we're all familiar with the alpha lipoic acid. I guess E2, remember there's 3 complexes in the pyruvate dehydrogenase complex, three little things. E2 is actually made out of something very similar to alpha lipoic acid. So, I don't know, maybe taking that supplement could help. I mean, I talked to this author, the mitochondria dude, and he told me it's like, you could spend like 30 years just studying this complex and you still may not find it, so ridiculously complex, but it's a mechanism among many others that are causing this horrible neuroimmune disease, or whatever you call it. I guess the World Health Organization calls it a neurological disease, but yeah, so there's so much going on here, it's too much, but if anything, maybe try insulin. I'm going to try to possibly try it with a doctor in small quantities and see what it does. Alright, thanks guys. Bye.